Okay, so in this, we're talking about probability. In section 5.1, we use simulations to imitate chance behavior. Fortunately, we don't always have to rely on simulations to determine probability of a particular outcome. Descriptions of chance behavior contain two parts. So we're going to really now talk about theoretical probability, what should happen. So the sample space of a chance process is the set of all possible outcomes, and a lot of times that's called sample space S. A probability model is a description of some chance process that consists of two parts, a sample space S and a probability for each outcome. Here's an example of a probability model. If you roll 2 die, there are 36 different possibilities that could happen when you roll a set of 2 die. So right there, that picture shows us the sample space of all 36 outcomes. Since the dice are fair, each outcome is equally likely to happen, so each outcome has a probability of 1 out of 36. Probability models allow us to find the probability of any collection of outcomes. An event is any collection of outcomes from some chance process. That is, an event is a subset of the sample space. Events are usually designated by capital letters like A, B, C, and forevermore. So if event A is what we're talking about, we write it as the probability of A, P parenthesis A. So if we're talking about the dice example, suppose we define event A as getting a sum of 5. So the sum of 5, there are 4 possible outcomes that occur in our chart where we get a total of 5 on the die. So that means the probability that event A happens is 4 out of 36, which we all know hopefully would be 1 out of 9. If event B is defined as not 5, the probability of B is 100% minus 4 out of 36, which is 32 out of 36. That's called the complement. So the probability of any event is a number between 0 and 1. All possible outcomes together must have probabilities whose sum is exactly 1. If all outcomes in the sample space are equally likely, the probability that an event A occurs can be found using the formula. The probability of A is equal to the number of outcomes corresponding to event A divided by the total number of outcomes in the sample space. You should know that from basic probability we've done in previous courses. The probability that an event does not occur is 1 minus the probability that the event does occur. And if two events have no outcomes in common, the probability that one or the other occurs is the sum of their individual probabilities. So, two events, A and B, are mutually exclusive, sometimes called disjoint, if they have no outcomes in common. So that means that they never occur together. So the probability of A and B happening would be 0. Event A would never occur along with event B, and. So we can summarize the basic probability rules in a simpler form. For any event A, the probability of A has to be between 0 and 1. The probability of S, the whole sample space, is equal to 100%. The second part here, the third bullet, the probability of A, you know this, is the number of outcomes over the total outcomes. The complement rule, the probability of A with a superscript of C, the complement to A, is 1 minus the probability of A. And the addition rule for mutually exclusive events, as long as A and B are mutually exclusive, that means that they don't ever happen at the same time, then the probability of A or B is equal to the probability of A plus the probability of B.